Here we're given a non-homogeneous differential equation with initial conditions. We're asked to apply the Laplace transform and solve for big Y of s, which equals the Laplace transform of y. So notice how we're not determining the particular solution y of t, we're only asked to find the Laplace transform of y, which equals big Y of s. So for the first step, we take the Laplace transform on both sides of the equation. So we'd have the Laplace transform of y double prime plus 4y prime minus 4y equals the Laplace transform of 2 sine 5t. Now for the next step, we'll use properties of Laplace transforms to rewrite the left side as the Laplace transform of y double prime plus 4 times the Laplace transform of y prime minus 4 times the Laplace transform of y equals, on the right side, let's write this as 2 times the Laplace transform of sine 5t. And now we'll determine each Laplace transform and then solve for big Y of s. To find the Laplace transform of y double prime and y prime, we'd apply the theorem stated here below, which would give us the Laplace transform of y double prime equals s squared times big Y of s minus s times y of 0 minus y prime of 0, and the Laplace transform of y prime equals s times big Y of s minus y of 0. So again, the Laplace transform of y double prime is equal to s squared times big Y of s minus s times y of 0 minus y prime of 0. And then we have plus 4 times the Laplace transform of y prime, again, is s times big Y of s minus y of 0. Then we have minus 4 times the Laplace transform of y, which is big Y of s, equals 2 times the Laplace transform of sine 5t. Using a table of Laplace transforms, we can find this formula here, where notice for our Laplace transform a is equal to 5, so the Laplace transform of sine 5t is equal to 5 divided by the quantity s squared plus a squared, which would be plus 5 squared or plus 25. For our next step, let's go ahead and clear the parentheses here by distributing, and we'll also simplify this product. So we have s squared big Y of s minus s times y of 0 minus y prime of 0 plus 4s big Y of s minus 4 times y of 0 minus 4 big Y of s equals, let's write the right side as 10 divided by the quantity s squared plus 25. Now we'll use the initial conditions and substitute 2 for y of 0 and 1 for y prime of 0. So we'll substitute 2 here and here, and we'll substitute 1 here. So this will give us s squared times big Y of s, and then we'd have minus s times 2, that'd be minus 2s, minus y prime of 0, which would be minus 1, plus 4s times big Y of s, and then we have minus 4 times y of 0. Y of 0 is 2, so we have minus 4 times 2 or minus 8. Minus 4 times big Y of s equals 10 divided by the quantity s squared plus 25. Let's go and continue on the next slide. And looking at the left side of the equation, notice how we have 3 terms that contain a factor of big Y of s here, here, and here. So let's go ahead and factor out big Y of s from these 3 terms, which would give us big Y of s times the quantity s squared plus 4s minus 4, and we're left with minus 2s, and then negative 1 minus 8 is negative 9, so we have minus 9 equals 10 divided by the quantity s squared plus 25. Let's move these 2 terms to the right side of the equation by adding 2s to both sides, as well as adding 9 to both sides. So we'd have big Y of s times the quantity s squared plus 4s minus 4 equals, we'd have 10 divided by the quantity s squared plus 25 plus 2s plus 9. And then for our last step, we'll divide both sides by the quantity s squared plus 4s minus 4. So simplifying, we have big Y of s equals 10 divided by the quantity s squared plus 25 plus 2s plus 9, all divided by the quantity s squared plus 4s minus 4. Now we could change the form of this, but I'm going to go ahead and leave it in this form. This is big Y of s, which again is the Laplace transform of y. So going back to the first slide, again we're only asked to find big Y of s, which we just found. Once again, 10 divided by the quantity s squared plus 25 plus 2s plus 9, all divided by the quantity s squared plus 4s minus 4. I hope you found this helpful.